Okay, so we have now introduced what a system of equations is, and what we're going to do over the series of the next several videos. Like I said, this is kind of a long unit, but over the next several videos, we're going to talk about different ways that you can solve them. So the first method that we're going to look at in this video is solving it by graphing. Okay, before we get started, there's a couple little caveats or disclaimers that I want to make about solving from graphing. The reason we start with this, I hope you'll see as we go through this video, is that it's a very intuitive process. It's a process that sort of kind of makes sense. If you understand from the last video that the solution is the spot where the lines are crossing, it's the point they have in common, it's their intersection, then it makes sense that by looking at a graph, you should be able to see where they cross. And so it's really a very intuitive sort of process. So that's the good thing. The bad thing, though, is that unless the two lines happen to cross at a very convenient point, it's really hard to get an accurate answer. And so because of that, we're going to have to learn some more powerful methods after this. Those methods will help us get very precise answers, but they're a little bit less intuitive, maybe a little bit more labor intensive. Okay, so we start with the one that's really the easiest to do, but frankly, it's the least practical. And that's the way that we kick this off. Okay, now there's one other little disclaimer or caveat that I want to make about the method of graphing. Typically, the high school student, when it comes to graphing equations in their math class, they just care about getting something on the paper that's the general right shape so their teacher will be happy. And you know, 9 times out of 10, I'm good with that. If you're supposed to be drawing a line that's sloping up and you give me something that's basically sloping up, I'm probably going to say okay. If you're supposed to draw a parabola that's kind of this big around and you draw a parabola that's about that big around, I'm probably okay. But when it comes to using a graph to find a solution to a system of equations, sort of good enough isn't good enough. The bottom line is that your answers to these problems will only be as correct as your graph is accurate. And so if you want to have any hope of getting right answers when you're solving a system using graphing, you have to take the time to make nice, neat, accurate graphs. There's no way around it. You just have to invest a couple minutes into the problem to make a nice, neat, accurate graph. That means use graph paper. That means use a ruler. That means take the time to actually count out all the little squares. Halfway isn't good enough if it's supposed to be all the way, okay? So you'll see in this video that I do that. I take the time to go nice and slow and get my graph as accurately as accurate as I can. And then from there, I can find the answer. All right, so with those little two caveats out of the way, I think we're ready to get started. Let's take a look at our one and only learning objective for this video. Our learning objective is simply to find a solution by using a graph. That's it. It's that simple. Remember, we said in the last video that technically the full name of a solution is it's the system's simultaneous solution, but it's pretty rare that mathematicians actually call it that. We usually just say solution for short. And that's what we're going to do. Now, from the last video, we talked about that when you get a system of equations, you might see a system presented in one of two different ways. So systems are usually is one word, drawn out or presented or shown to you. I'll say presented, I guess. Presented, displayed, described, whatever the right word is there, in one of two ways. Okay, so you might see either one of these two scenarios. Okay, so one or the other is what you'll see. The first one, the reason why we call it a system of equations, we said yesterday, is you might see it presented as two equations. So unlike yesterday's video, I am going to take the time in this video to make good, accurate graphs and equations that match each other. So I'm going to start with a system of equations like this. And over here, so that's the first way that you'll see it presented is as equations, or you might see it presented as a graph. And because it's going to directly tie into this lesson, I'm going to take the time to actually graph these two equations nice and neat. I'm going to use this as a little bit of a review of how we graph something if it's in point or slope intercept form, if we're in slope intercept form. So in slope intercept form, what we've learned before is that the number at the end, the constant, is the value of the y-intercept. And we usually have b represent the y-intercept. So in this thing, our y-intercept is 3. And the number in front of x, which in this case, the number in front of x is a sneaky ninja. It's the number 1, right? That number tells us our slope. And we like to think of slope when we're making fractions or when we're making graphs. We like to think of slope as being a fraction. So the sneaky ninja 1, if I put it over top of another 1, there's my fraction. And so I've got my slope with my rise over my run, and I've got my y-intercept. Okay. Now, like I said, for my graph, I'm going to take the time to go nice and slow and draw a good, accurate graph using my ruler. So there's my y-axis. And here's an x-axis. Hopefully this graph ends up being big enough. One thing that you may want to do as you go through practice problems is just make sure that you make your graphs nice and big so that you can fit your lines on them. Okay. So for this line right here, my y-intercept is 3. So I'm going to count by ones here. So this is 1, 2, 3. And I'll count by ones over here. So 1, 2, 3. So if my y-intercept is 3, then on the y-axis, I'm going up 3. So I've got a point right there. And then I'm going to count my rise over run as a 1 over 1. Boom, boom. And I've got a point there and a point there. And of course, we can always think of it as going a -1 over -1, because that would simplify to be the same way. So a down 1, left 1 would also work. Okay. But I'm getting a line that looks like that. And then again, I'm using a ruler. I'm taking the time to make a nice, accurate graph. I'm grabbing my ruler here and trying to make a nice, accurate graph. Mine's not 100% accurate, but it's pretty close. And then I also like to label my graph just so I know which line goes with which equation. Okay, so there would be my first equation. And there's a quick little review there of how we come up with those equations. So what I would encourage you to do, maybe pause the video real quick and see if you can make a graph of this equation on the same axis. Okay, we're going to want to always graph our system of equations. We mentioned this in the last video. We're going to always graph them on the same axes because these are connected to each other. So we want to show them in the same kind of graphical environment, if you will. All right, so take a second now, pause the video and see if you can graph that. All right, so hopefully you've made that graph. And the first thing you should have done is recognize that your b value here at the end, your y-intercept, is a -1, because remember the sign goes with the number. So -1 is your b value. So it's going to be down here on the y-axis. And then here my slope is also a -1. There's my slope. But I like to write it as a fraction. And so if I want to make a fraction, I just put it over a +1. That makes it a fraction. Now, the one thing that we often see students make a mistake with when they're dealing with negative slopes is, remember, the negative sign goes in the top, or it can go in the bottom, but it doesn't go in both, right? It's one or it's the other, but it's not both, right? So from this point, my y-intercept, from my y-intercept, this tells me I have a rise of -1. So I'm going to go down 1. And I have a run of +1. So I'm going to go right 1. So down 1, right 1, down 1, right 1, so on and so forth. Or like I said, you could think of the negative sign as being in the bottom, because that would still equal -1. So if I had a +1 over -1, now my rise is up 1 and my run is left 1. Okay. And that's the case always. We've seen that when we graph before. It's always the case that you can go in both directions from your y-intercept. You just have to be careful with the way that you're handling those signs. Okay, so there is a pretty decent, again, it's not 100% perfect, but it's a pretty decent graph of our other equation. This was the equation y equals -x minus 1. Okay, and like we saw in the last video, these two lines cross. They happen to cross right here. And as I was saying at the beginning of this video, if the place where they cross, the point that they have in common, that intersection point, if that's going to be the solution, then graphing is a great, just sort of natural way to find it, because once I have my graphs on the paper, I can see where that point is. And so that point up there there's my solution. It's the point, my x value is -2, and my y value is +1. So it's the point -2, 1. Okay, and with these types of problems, that's always going to be the case, that your solution is a point. Okay, it's an ordered pair. So that's what you're going to have to write for your answer. So we basically more or less have just done an example. Okay, this is, we started with what we knew from yesterday, is that they look like this or they look like this, one or the other. And now we've just talked about, well, the way that you solve it then is you just find that point right there. That's your solution. That's basically the idea. It really is more or less that simple. The hardest part, of course, is making the graph. That's the hardest part. And sometimes the system starts off as a graph, right? If they gave you this to start with, then finding the solution is really, really easy. You just look for that point, you write down the ordered pair, you're done, okay? If they give you the equations to start with, if this is what you start with, then that's the hardest part of the problem, is taking this and turning it into a graph so that you can find that point and write the point down. But that's your basic process. In fact, let's jot that down as being our basic process. So how to solve using graphing. Okay, so we basically have this in 3 steps. And actually up here, I only did 2 steps. So we'll talk about that 3rd step in just a second. But step number 1 is you need a graph. Okay, step number 1 is you need a graph. So if they give you the graph to begin with, then step number 1 is done. You're good. If they don't give you the graph, then you've got to find your slope, find your y-intercepts, draw your graph, okay? So there we go. You need a graph. So that's step number 1, get a graph. Get a graph. That's step number 1. Step number 2, find the point where they cross, specifically the coordinates, the ordered pair that describes that point, okay? Find the coordinates of the point. I'm going to say the point of intersection, if we can borrow that word from geometry for a second, intersection. Okay, the intersection point, remember, that's the point where the lines cross, the point that they have in common. Okay, that's what we're looking for. Now, I said, though, a minute ago, there's actually a 3rd step. And the 3rd step is really particularly important when it comes to the method of graphing. We want to check our answer. And remember, the whole idea of a simultaneous solution is it's the point where both lines have the same x value and both lines have the same y value. There's only one point where that happens, right? Like, for example, right here, both this point and this point, they both have the same x value. They have an x value of 0, but they have different y values. This one's way up here at 3. This one's way down here at -1. There's only one point where they have the same x and they have the same y. That's what you're finding. And because it has to be true for both of them, when you check it in both equations. Okay, and like I said, in our class, we will usually have 2 equations. If you have more than 2 equations, you've got to check it in all of them. Okay, but in our class, we'll usually have 2. So that's our basic process. So maybe let's visit, how would I check this solution in these equations? Let's take a look at that real quick. Okay, so here's our check step. I'm going to take my 2 equations. So my 2 equations, I've got them, whoops, sorry. Need a little more room on my desk. I've got the first equation is y equals x plus 3. And the second equation is y equals -x minus 1. Okay, so there's my 2 equations. My solution is -2, 1. That's my solution. Okay, so now we're going to check this point in both equations. That's what we're going to do right now. So what that means is I'm going to take the x number and I'm going to plug that number in for x. So this x, remember when we substitute, we use parentheses. So that x is going to turn into a -2. Now the +3 is still there. That hasn't gone anywhere. The equal sign is still there. And the y is going to turn into a 1. Okay, and again, I like to use parentheses when I substitute. We don't really need those parentheses right here, but I like to use parentheses when I substitute. And then we start to simplify, right? So the first thing I would simplify is I would get rid of the parentheses I don't need. And in this case, I really don't need either parentheses. They're good. So the only thing I need to do is just combine these two like terms together. -2 plus 3, well, that just happens to equal 1. -2 plus 3, that equals 1. So I've simplified the right-hand side. And then I just verify, does 1 equal the left-hand side? Does 1 equal 1? Yes, it does. So this one checks out, okay? I will say in the check step, the most common mistake that we see students make is notice the y is first here and the x is second here. Traditionally, that's the way that we write it. But up here, they're the other way around. So the most common mistake we see is that people take this x number and they plug it in for y by mistake. That might sound like a silly mistake, but if you're rushing and you're not paying super attention, it's a really easy mistake to make. So when you're doing these problems and you set up to do your substitutions, be careful to make sure that your x number is actually going where the x goes, and that your y number is actually going where the y goes. Okay, so just be careful with that. And then from there, you simplify. So in this case, again, these parentheses don't do anything. I can just drop them. Here, in order to get rid of these parentheses, I've got to do the opposite of -2. So the opposite of -2 is a +2. Or you might think of this as a -1 times -2, however you think of that, but you should get a +2. And then -1. When I combine 2 minus 1, I'm going to get a 1. 2 minus 1 equals 1. On the left-hand side, I still have a 1 equals. And then I just check. Do the two sides match? Does 1 equal 1? Yes, they do. So I'm good. That works. All right. So that's our check step. So this is the basic idea of how to solve by graphing. You need a graph. If they give you a graph, then you just jump right into step 2. If they don't give you a graph, then you go through the process of making it. Okay, then you find the point where they cross. That is your solution. So in a very real sense, once you find that point and you write down the ordered pair, there's a real sense in which you're done with the problem. Okay, but in graphing, because it's really easy to be a little bit off, if your graph is a little bit messy, or if it turns out that the answer happens to be a fraction or something like that, it's really easy to be a little bit off. So it's important when you're solving by graphing that you check the answer to make sure that the number that you think is the intersection point actually is the intersection point. Okay, so that's it for this video. There are a couple little wrinkles that can pop up when you're solving by graphing. And so I am going to publish in just another minute here a second video where I go over a couple of those wrinkles that you might see, things you need to watch out for. But this video covers the main idea. This is the main idea. Everything you're going to see in the next video uses the same 3 steps, but it's going to apply them in situations that might be a little bit different or a little unique, just things that you need to be careful of. Okay, so thanks for watching this video. Have a good one.